We have a rather simple answer to the question of when two covering spaces are isomorphic if we have fixed base points. Okay, but we want to use that to understand two different things. One is, what if we are allowing the base point to be changed? That is, equivalently, we have not picked a base point. And more interestingly, what about symmetries of covering spaces? And both these will be based on the following, which is quite simple given what we have seen. So let's take a covering map P from y0 to x0, and let's pick another point in the fiber. Okay, so let's take x is let's take y in P inverse of y0. Now we already dealt with this and we already know how to parameterize y. Okay, namely we take a path. So let's just take our covering space again. Here we had this point y0 and we had another point y, and we took a path which joined these two, and both of these go to the point x0, but the path goes to something interesting. Okay, so let's call this path alpha, and we look at P composed with alpha, and what we know here is that y, so this is equal to, if you wish, or it corresponds to the set of all hg with g in G, right cosets, not in H, G, where we have G is the fundamental group of X itself, and H is the image of the fundamental group of Y. Okay, we'll often just think of this as the fundamental group of Y contained in, because this is an inclusion map. So we look at the set of right cosets, or so this is denoted G by H, and we can think of the fiber as equal to or corresponding to these cosets. Okay, so now given such a guy, so we have the map P. Okay, so we can ask the following question, which is, what is the group corresponding to Y? So that is simply, what is P star of pi 1 of y1. Okay, so remember y1 also goes to x0, so this is contained also in pi 1 of x0. And given what we have seen, this is actually rather easy to answer. We know the change of base point map, so let me say solution. Let's just note, first of all, you note that pi 1 of y0 is going to be, we take pi 1 of x y with, pi 1 of y1 is what I want now. So let's write it cleanly. Pi 1 of y1 is going to be, well, remember what we have is, we have y0 here and y1 here, and if I took any loop at y0, call it beta or something, I get a loop by taking, so alpha went in this direction, alpha bar beta alpha. Okay, so this is going to be equal to alpha bar beta alpha, where beta belongs to pi 1 of y1, y0. Okay, and alpha is this path here which goes to a loop. Okay, so therefore P star of pi 1 of y with y1 is going to be, well, so is going to be, let P composed with alpha, this class be G, which we use notation. So this is going to be P of alpha bar beta alpha, where beta is in pi 1 of y0. So if we push them forward, this is going to be equal to G H, so the first one is inverted, G inverse HG, where H belongs to H, okay, which is simply the conjugate group G inverse HG, often denoted as H to the power of G. Okay, so let P come where let P is this thing over here. So we just know that it's a conjugate group. So the answer is very simple, namely the elements in the fiber correspond to right cosets, and you take conjugacy by the corresponding element in the right coset. Now you notice that, so let's just remark, we need a sanity check if G prime is going to be H times G. So the right cosets are the same, then G inverse HG is going to be the same as G prime inverse times H times G by elementary G prime by elementary algebra, because we can substitute H times G here. So this is H times G and H gets absorbed there, and this, when we invert it, becomes G inverse times H inverse, and H again gets absorbed into the group sitting in the middle. So either way, what you see is the answer is simple, that we have the group of conjugates, that is the group that is normal. Okay, so note here the converse is kind of 2. So remark is that it follows that if H prime is conjugate to H, then H prime is of course G inverse HG. That's your definition of conjugacy for some G, and that G is alpha. Okay, and hence we can see H prime is going to be P star of pi 1 of y1, where you can presumably guess y1 is going to be by definition alpha tilde of 1. We just reverse the construction. So the point is that the groups for the different base points are exactly the conjugates of these groups.